Hi, welcome. Today's problem is about finding solutions of this non-homogeneous linear system x minus 2y minus 2z equals b1, 2x minus 5y minus 4z equals b2, and 4x minus 9y minus 8z equals b3. And as you can see, the system doesn't only have numbers and unknowns, it also has parameters b1, b2, and b3. And the solution will depend on these parameters, but also the existence of the solution will depend on these parameters. And we're asked to find the solution and find when it exists, depending on the values of b1, b2, and b3. So now you should pause the video, solve the problem, and come back and compare your solution with mine. And we're back. Let's start by solving this system as if though b1, b2, and b3 were numbers. So we write the matrix of the system, which is 1, minus 2, minus 2, b1, sorry again, 2, minus 5, minus 4, b2, and 4, minus 9, minus 8, b3, and we do elimination. So we multiply the first row by minus 2 and add it to the second row, and we multiply it by minus 4 and add it to the third row, and we get 1, minus 2, minus 2, b1, 0, 4 minus 5 is minus 1, 4 minus 4 is 0, and minus 2 times b1 plus b2. And here we get 0, 8 minus 9 is minus 1, and 8 minus 8 is 0. Finally, on the right-hand side, minus 4b1 plus b3. And you can already see that something's going to happen here, but let's do one more step. So eliminating further, we get 1, minus 2, minus 2, b1, 0, minus 1, 0, minus 2, b1 plus b2. And in the last row, we replace it with the last row minus the second row, and we get 0, 0, 0, minus 4b1 plus 2, or so minus 2b2 is minus 2b1, minus b2, and plus b3. I hope I did this right. OK, so now let's think of it as a system again. The last equation says 0 equals this expression in b1, b2, and b3. So this is something to note down. If minus 2b1 minus b2 plus b3 is some number that's not 0, then the last equation is going to say 0 equals non-zero. It's never going to be satisfied, and the entire system is never going to have a solution. So in this case, we have no solutions. If this is equal to 0, so minus 2 b1 minus b2 plus b3 is equal to 0, then let's do one more step in this, on this matrix here. Let's turn this number into 1 by multiplying this row by negative 1. And let's use it to eliminate this number here as well. So in this case, we get, let me write it from the last row, which now becomes 0, 0, 0 equals 0, which is fine. The second row becomes 0, 1, 0, 2b1 minus b2. And the first one, to get rid of this minus 2, we multiply this row by -2 and add it to the first one. We get 1, 0, -2. And here we get b1 plus 4b1, which is 5b1, minus 2b2. The reason why we did this was to get the identity matrix here. And now let's solve this. These two columns, corresponding to variables x and y, have pivots in them. So these are the pivot variables. This column here has no pivot in it, so it's a free variable. And now we're going to calculate the solutions by picking particular values for z, and then calculating the values for x and y. We have two kinds of solution. One kind is the particular solution. So this one solves ax equals b. There's only one of them, and we get it by setting the free variable equal to 0. Setting the free variable equal to 0, we get, well, this is equal to 0. The second equation says y equals this thing here, so 2b1 minus b2. And the first equation says x minus 2 times 0 equals this expression here. So 5b1 minus 2b2. That's our particular solution. The next kind is the special solution. So remember, those solve ax equals 0. There's as many of them as there are free variables. In our case, there's only one. And we get it by setting all free variables equal to 0, except one equal to 1, and do it for every free variable. So in our case, there's only one free variable, and we set z equal to 1. The solution that we get in this case, and remember we're solving ax equals 0. We don't care about the right-hand side anymore. So z is 1. This second equation says y equals 0. And the first equation says x minus 2 times 1 equals 0. In other words, x equals 2. So the special solution is 2, 0, 1. And now all solutions are of the form x equals a particular solution plus any multiple of the special solution. Let me recap. In case this particular combination of parameters is not 0, there's no solutions. In case this particular combination of parameters is equal to 0, there are solutions. There are as many of them as there are real numbers c, and they're all of this form for these two vectors. And that's all I wanted to say today.